Hey, I'm making this video to show off my Amstrad CPC emulator. Let's run the emulator. So, as you can see, you're dropped right into the basic shell. This is an emulator written in Rust, which is a compiled language comparable in performance to C or C++, which makes it quite suitable for this kind of task. And the hardware it's emulating is the CPC 464, which was the lower end model, which originally only had a tape drive, but instead of emulating the tape drive, I chose to emulate the optional floppy disk. And the first thing I want to show off is the debugger. So I built a debugger into this to help with finding issues with the emulator. So if you press F12, on the right hand side you can see you are dropped into the debugger shell, and you see the current instruction is disassembled right here. And you can do various things now. For example, you can look at the CPU registers. You see the registers here, and also the flag register with the various flags. And what you can do, for example, now is if you want to debug something specific. For example, let's imagine we want to debug the basic print statement. We can set a breakpoint. And this sets a breakpoint at the address of the basic print statement. So if we now continue the emulation, and use the print statement, print test, instead of executing, we now get dropped back into the debugger shell, and you see that the next instruction is actually a call. So let's single step to that. And you can see the address of the call right here is now the current address, and there's another call there. And we can even look at a couple of more instructions without executing them. So if we say disassemble, it shows us the next 10 instructions instead of just the current one. Let's actually remove the breakpoint again. So now we have no active breakpoints. And if we continue now, you can on the left hand side see it's actually executing the print statement. And this was quite helpful in the early days of the emulator to track down some bugs. And it was quite a useful tool. Someone who was more experienced in writing emulators suggested emulating not only the machine but also including a debugger. And this was good advice. This was very helpful for me. So what I want to show off now is to show off an actual game. So if you press F5, you can load a disk image into the emulator. In our case, let's load the game Fruity Frank. And we can display the contents of the floppy disk. And we can see the disk was successfully loaded, and Fruity Frank is indeed on that disk. And before I start the game, I want to take a few seconds to actually talk about the audio emulation. So the audio emulation is not perfect yet, as you will see when I start the game and the audio starts playing. The noise channels that the CPC had are not emulated at all yet, and also the volume is not handled correctly, so it sounds a little bit weird, but you can recognize the melodies it's playing. And yeah, let's actually run Fruity Frank. And yeah, I had a lot of fun in writing this emulator. I worked in the dark for a long time without seeing any results, and one day when I finally was able to emulate the basic prompt or even run some games, I was quite satisfied. So yeah, that's my summary of this emulator project. Let's just enjoy the demo of Fruity Frank for a little bit. Okay, let me actually turn off the sound. And yeah, if you want to take a look at the source code, it's freely available under the MIT license, and I put a link to the repository on GitHub in the description. So thanks for watching, and yeah, hope you enjoyed it.